Year 12. This lesson, I will be going over the solutions to the independent independent preliminary exam for Year 11 for 2023. I'll start with the multiple choice here. First of all, the first question is, which statement best describes the mechanical property of ductility? Ductility is the ability of metal to be drawn into wire. So it's B here. 2, which metals have a face-centered cubic lattice structure at room temperature? You have to eliminate those from the other alternatives that obviously don't have a face-centered cubic. For example, tungsten here and titanium and vanadium here. And so all of these in A have a face-centered cubic structure. So gold, silver, aluminium, and platinum. Question 3, what are the 3 primary bond types in materials? These are just straight out learning, so you should be able to do this if you've studied effectively. Metallic, covalent, and ionic, they're the 3 primary bond types. Question 4, what mainly distinguishes thermosetting polymers from thermosoftening polymers? Thermosetting polymers are always cross-linked. They have a 3D structure, and thermosoftening polymers are not cross-linked. They don't have any cross-linking at all. They're bound by secondary bonds across the chain. So B is the correct answer there. This question, a lot of students found quite difficult. What's the magnitude of force A if the resultant of the 2 forces is 172 kilonewtons acting 30 degrees upwards to the left? I always advise you to draw the information, make it a bit more obvious other than just reading it. And so here's the result going up at 30 degrees. And you have to realize that the resultant of this force here in the vertical direction will be 172 sine 30 degrees. And so that is the vertical component of the resultant force, and the vertical component of A will be FA, which is the force of A sine 60, because that will be the vertical component of that. And there's no vertical component to a horizontal force. And so the vertical component of that force, A, has to equal the vertical component of the result. And 100 kilonewtons is the correct answer. And it's C in this multiple choice. Question 6, a block of mass 75 kilograms rests on a horizontal surface. The horizontal force required to get the block on the point of sliding is 150 newtons, sorry. What's the coefficient of friction between the 2 contact surfaces? So you write down your formula, which has been given to you on your formula sheet. So force of friction equals mu(n). We've got to find the coefficient of friction. And so that equals force of friction over the normal. I always ask you to write down the data here, make sure you use the same units and or the correct units here. And so it's 150 over 750, so it's 0.2, and it's a ratio because the newtons cancel out. So choice A is the correct answer for question 6. Question 7, which processes are used to shape ceramics? Die casting is not used. Lost wax casting is not used to shape ceramics. And injection molding and vacuum forming generally don't shape ceramics. In fact, vacuum forming definitely doesn't. So D is the correct answer here. Got extrusion. slip casting and press and float mold use form glass objects. So D is the correct choice on question 7. Question 8, what are the units for the charge movement in a conductor? The charge movement is measured in amperes, so C is correct for question 8. Which statement best identifies Pascal's principle? Pascal's principle says that pressure is constant in a closed hydraulic system, and B is the correct answer there. A 15mm diameter metal bar, 350 long, extends 4 millimeters at failure when subjected to a tensile load of 50 kilonewtons. What's the strain in the bar at failure? So you write down your formula. Strain is the change in length over the original length. Make sure you realise that the change in length will be in the same units as the original length, so they cancel, so strain will be a ratio. And put your information down here, your data here. Make sure you put the, that should be millimeters there. Just notice. Put your units there. And so it's 4 over 350. So the strain is 0.011. And it's shown here as a percentage. So we convert it to a percentage. So it's 1.1%. So choice B is the correct answer for 10. Question 11, which cast iron has carbon in the form of graphite plates or plates? Grey cast iron is the correct answer there, so 11A is the correct one. An exploded pictorial view of a cap screw and the washer is shown. And so you've got the cap screw here, it's got metric thread, it's 10 millimeters diameter, the pitch is 1, and it's 30 long. The full thread length is shown here, that the cap screw has the thread going along the entire length of the shank. What are the common AS drawing standards, AS 1100 drawing standards for the cap screw's head thickness and the diameter of the washer? You know, the head of a bolt or a cap screw is 0.7D, and the washer diameter is 2D. So the washer will be twice 10, which will be 20 millimeters, and the head will be 0.7 times 10, which is 7. So D is the correct answer there. 2 types of metal casting defects, X and Y, are shown. What is the common name for these 2 casting defects? You've just got to learn this. This is primary piping, and that's where the expansion occurs. But if you've got rapid cooling on both sides, you'll get the freezing of the outer layers of this casting, and it will leave a big contraction hole in the centre, which is called secondary pipe. So 13A is the correct answer. The shape of Australia, measuring about 300 millimetres by 200 millimetres, is to be cut from 10 millimetre thick plate glass. What would be the most appropriate method to use to cut the shape? Water jet cutting is the appropriate method there, because it doesn't heat the glass. And it is a very effective way of cutting glass. So the answer to 14 is A. Question 15, electrical circuit with 3 resistors and a 12-volt power source is shown. What is the total resistance in the circuit? So these 2 resistors are in parallel. So the idea is to work out the total resistance in the parallel, and then that you just add it to this one because it'll be in series. So the resistance in parallel, make sure that you know it's 1 over R equals 1 over R1 plus 1 over R2. And when you get this answer, lots of students don't realise you've got to invert it. And so you invert it to get R, so it's 12 over 5. So the resistance from this parallel circuit is 2.4 ohms, and then you just add the 3 to it, so that's 5.4. And so alternative D is the correct answer. 15. What's the most desirable property required from a prosthesis, such as a hip joint? These are all desirable properties, but this is the most desirable, biocompatibility. So D is the correct choice for 16. Question 17, a bolt having a tensile strength of 200 megapascals is subjected to a tensile load of 50 kilonewtons. What's the appropriate diameter for the bolt? So you use your formula here, you get from the formula sheet, put all the data down here. Now I've used pi d squared 1/4, or you could use pi r squared, but then you have to multiply by 2 to get the diameter. Make A the subject, and the formula for the area will be pi d squared 0.4 multiplied by 10 to the minus 6, because we want the answer in millimeters. Then you just do this calculation. It might be a better idea to put a couple more steps in here. And so D was 17.84, and so 17C is the correct answer. Which best indicates the toughness of materials on the stress strain diagram? Toughness is always indicated by the total area under the stress strain curve. So B is the correct answer for question 18. Name the polymer forming process shown below. You should be able to draw this and recognize it. And this is injection molding. So D is the correct answer in 19. Question 20, which best describes annealing of a low carbon steel? Annealing is softening the steel, and you have to heat it up to red heat, soak it, and then allow it to cool slowly to get it to be as soft as possible. That's full annealing, and so C is the correct answer for question 20. Now we go on to section 2. The statement here, biomedical engineers bridge the gap between technology, medicine, and biology. And you can see this question's worth 6 marks, so obviously 2 will be allocated to that, 2 to that, and 2 to that. And it's best to answer the question like this here. You put the heading technology so you don't miss that, and then you've got to discuss identify the means to identify issues and provide points for and against. And so you explain that how the biomedical engineer has to bridge the gap between technology and with reference to a hip prosthesis. So biomedical engineers' knowledge and skill with materials and production methods are necessary to produce structurally sound hip prostheses that will perform as required and specified by the medical professionals involved with hip replacement. Make sure you relate each of these aspects to the hip prosthesis. Many students didn't do that. And as I said, it's best to set it out like this so that there's no doubt in the marker's mind that you've addressed each of these aspects. And you can get a good idea of how the marks will be allocated by counting the number of aspects you've got a tree and just seeing what the marks are worth. Question 21, describe how the design of modern motor vehicle braking systems have impacted society compared to those used 70 years ago. You've got to describe, produce the characteristics and features. So safer vehicles isn't a description. You've got to add the description provides users with more confidence with this brake compared to, let's say, front brake 70 years ago. And so if you just mention it makes vehicles safer, that's not a description. You've got to give the characteristics and features. Say, safer vehicles because, and then that will be the description. And it's not a bad idea. You can see that it's worth 4 marks, so it's not a bad idea to provide possible negatives as well. Question 21. 3 forces X, Y, Z shown below are in a state of equilibrium. Determine the magnitude of forces Y and Z. Now, this was done really poorly by my class, and I'll just go through it graphically and then I'll show you how to do it analytically. So, first thing that I think you should do if you're doing it graphically, you should put a scale down, and then you use their diagram to draw the force diagram. So I've used Bose notation here. So A goes between that force and that force, B between those 2 forces, and C between those 2. Now you start with the known force. So you draw that 30 units long, which will be 60 millimeters long. And then you label it. That'll be little a, little b. Going clockwise, the next force is BC, and it goes down, but we don't know how far it goes down. But we know that this next force is CA, and it's got to go through A, so you just produce it on there, and you just scale off these forces, and you have got the magnitude of those 2 forces. When you're doing it analytically, you can say the sum of the vertical forces equals 0 because they're in equilibrium. And so the vertical force of Y, the vertical component of Y, will be Y sine 30, and it's going down, so it's negative Y sine 30. And the other vertical force here will be Z sine 45, and that's going up because the sense that Z sine 45 equals 0. So you get Z in terms of Y. So the next thing you do is say sum of the horizontal forces equals 0, we could write positive. And so the horizontal component of this force has got to be 30 kilonewtons because it's a horizontal force. That will have to equal the horizontal component of that force plus that force as well. And so we've got minus 30, which is the 30 kilonewton force, plus Y cos 30, remember cos is the horizontal component, and plus Z cos 45. And you substitute for Z in this equation, and you'll have one unknown in the equation. You'll have Y there, and so you get what Y is equal to. It's 21.96 kilonewtons, which is pretty close to what we got graphically. And then you substitute that in this equation, and then you can get Z here, which is 15.53, which is pretty close to the graphical method. This was really poorly done. The major mistake was when the top view was sketched, a lot of students didn't put it as a projection of the front view. They put the view over here somewhere or down here, and you immediately lost marks with that. Make sure that you, when you do a circle, you put a center line in, do a major center line for center of the object and make sure you've got circles here, so therefore whatever center line there. And that was worth 6 marks. Question 22. The 4 holes in the 10mm thick plate, so we're talking about these 4 holes up here, and it's 10mm thick, are to be punched 1 hole at a time using a 94 kilonewton hydraulic press. Assume the shear strength of the base material is 300 megapascals. Calculate the largest diameter hole that can be punched by the 94 kilonewton hydraulic press. So you just use, this hasn't been set out correctly. It should have data here, like I asked you to do, so that you can get marks. If you get the wrong answer here, the marker can go through your data and see whether it's a mathematical mistake or some other mistake. And remember, if you've made a mathematical mistake in another part of this question, you can't be double penalised. So you could get full marks for a mathematical mistake, for an error made in mathematics. And you can't tell what the error is if you haven't got all this data. Okay, so we've got the shear stress or strength is 300 megapascals, and that equals the load, which is 94 times 10 cube newtons, and you divide that by the area of shear, which is the perimeter of the hole multiplied by the thickness, which is pi d. So the answer will be 10 millimeters. But that should be set out much better than that. Okay, so that's the answer to question 22B. Question 22C. Determine the compressive stress in the punch while punching the largest diameter hole in the bracket base using the 94 kilonewton hydraulic press. And you make sure that you know that the area here is the perimeter of the hole, which is pi d, times the thickness. And the area down here, because it's applying 94 kilonewton load to a punch which is 10 millimeters diameter, it's use this formula: compressive stress equals load divided by the cross-sectional area of the punch. And so you've got 94 times 10 cubed. Make sure you don't put kilonewtons into the equation. You've got to put the numerical value, divided by pi r squared, and we're using 10 millimeters. If you got this one incorrect, make sure that you know how to do this. If you use the incorrect answer up here, you won't be double penalised. So make sure that you have a go at it. If you couldn't do this at all, just tell the examiner you're assuming the hole is 5 millimeters diameter, and then put it in down here, or 10 millimeters diameter, or whatever, and you'll get 4 marks for it. So it's worth 3 marks. Describe 3 impacts of microcircuits, integrated or circuits, on society. So you've got to describe. You just can't say smaller electronics. You've got to qualify that, so it's less cost to consumers due to less production costs, and put possible negatives. That question was done quite well. Question 23, describe 3 significant advantages of using CAD, which is computer-aided drawing, design, and engineering. Once again, you describe and the characteristics and features. Now, I didn't put a description here. You've got to, if you just say more accurate than hand drawings, these are just points I put down here. It's not the answer for a description. You should say more accurate than hand drawings because blah, blah, blah. Right, so that will be a description, but this is just a detail, it's a statement. So faster to produce and less handling, which reduces the cost of it and so forth. Okay, so make sure that you know that these are just the possible points and it's not a correct description. That's worth 3 minutes. Next question was really poorly done, and I'll just go through both methods of doing this question. So here you have a lever with input force F. Now here's F here, and it's at 45 degrees. And the lever is pivoting at A here, and it's balancing the 800 Newton load as shown. Calculate the reaction at force A. So the best way to do this is using the 3-force rule. And the 3-force rule says that if the body's in equilibrium and 3 forces are acting, the 3 forces will all pass through the same point. So you've got this force here, use their diagram, and you draw a straight line up there, you draw a straight line up there with this force, and there's the point of application. So you've got a force going down there, you've got a force going down there or up, and you've got a force going down there. Now this force obviously has to go up because that force is going down, that force is going down. So this force has to balance those 2 forces. So it's going up, but you don't have to know that. Now you'll be able to see it from the force diagram. Then use Bose notation. So A goes between those 2 forces, B between that and that force, and C between those 2 forces there. Then use your scale here, and you scale this off. So 800 newtons I've made to be 40 millimeters, so that's 40 millimeters, and that is force AB. So you put little a, little b there. Then going around, the next force is BC. It's got to go through B. It's got to be parallel with that, and draw a line parallel with that. And you can go up or you can come down, doesn't matter. And then the next force will be CA, and it's got to go through point A, so you just extend that on. All the forces are depicted by the arrow here, so it goes down, and they all have to go in the same general direction. So you can see that this force, the reaction force, is going up to the right. And all you have to do is use the scale to measure that force there. So it works out to be 59 millimeters, and so it's 1180 newtons. And make sure you use your protractor to find the angle. I've found it to be 73 degrees. Now to do it analytically, all you've got to do is say, we're going to break this force that's going through the reaction there, or the pivot, into vertical and horizontal components. So the vertical component will be FAY here, that's FA there, and the horizontal will be FAX. So I'm saying the sum of the vertical forces on the object equals 0. We've got positive. So I've got FAY there. I'm saying it goes up. And if I get a negative answer here, it means it goes down. So FAY minus 800, which is this force here, minus 800, minus the vertical component of this force here, which is 333. Okay, because I've found that force, I took moments about A there to find that force over here. And so I've got 0.707 F. So the vertical component of that force here will be sine 45 F. Sine 45 is 0.707. So that's going anti-clockwise. So it's negative 0.707 times the perpendicular distance of that force about that pivot point, which is 0.6 or 600 millimeters, but use meters. Then I've got this force here, it's going to go clockwise about point A, so that is 800 times 0.25, and that equals 0. So I've found that force there, I've found F to be 471.5 newtons. And then using this, to get 333, I've multiplied 0.707 multiplied by 471.5 to get 333. So therefore I found that FAY, so this vertical component here, is 1133. It's positive, so therefore it's going up because I've said that it's positive over here. Then sum of the horizontal forces equals 0 because it's in equilibrium. So you can see that the horizontal component of that force has to equal the horizontal component of that force because there's no horizontal component to a vertical force. So I've got FAX, I've said it's going positive, minus 333, which will be the same as that because it's 45 degrees. So that equals 0, so therefore FAX equals 333 newtons. Then, so we've got that force there, we've got that force, and to find the resultant of those two forces, we have to use Pythagoras. So the square of that equals the sum of the squares of the other two forces. So that's Pythagoras, and so it's 1181. But that's not all. And that's pretty close to what we found here. That's not all. We've got to find the acute angle of the horizontal, which will be theta. So tan theta will be equal to FAY over FAX. So tan theta is FAY over FAX, and that's 73.6 degrees, which is pretty close to what I measured with my protractor. So that was worth 4 marks. Really poorly done. Calculate the velocity ratio of the lever using F as the input force. So velocity ratio is equal to mechanical advantage at 100% efficiency. And so the mechanical advantage at 100% efficiency will be the load over the effort. And we're assuming that 800 is the load and the effort will be 471.5. Now, if you haven't worked this out, you just, for that value, just tell the examiner, assume F is equal to 500. But don't leave it blank. And so that works out to be a velocity ratio of 1.7. So in other words, F is going 1.7 times the speed that 800 newtons is going. Or you can use the velocity ratio as the distance the effort moves over the distance the load moves. Now you've got to get this perpendicular distance, and that will be 0.6 tan 45. So that's the moment of the force. Okay, and so it is pi d multiplied by 0.6 tan 45, and that will give you that distance there. But I haven't put it in down here because the pi d will cancel out with the distance the load moves. So the distance that this is the load here, that will be pi d times 800. Right? Oh, sorry, the distance of load move will just be pi d, which is, will work out to be 250 because the pi's cancel. So it'll be 250. And so you get 1.7. That's the way we work it out. When we say the velocity ratio, it is mechanical advantage of 100% efficiency. Okay, the bracket with an angular rib is shown below in the orthogonal projection, taking size directly from this drawing. Sketch a pictorial drawing of the bracket when viewed in direction A. And this was reasonably well done. I've done it in isometric view, and it's best to use isometric, not oblique. And that's it. So I hope you understand that, but let me know if you have any questions, and I'll speak to you next week.